Welcome to iTTV for Form 4 Chemistry. In today's lesson, we're going into a new chapter, the periodic table of elements. And the title of this lesson is the periodic table. In the previous lessons, we have learned about atomic structure and that electrons are arranged in shells. But the periodic table, an example of which is behind me, contains 100 or more elements in it. The elements are arranged according to their proton number. Remember, the proton number is the number of protons in the nucleus of an atom of an element. Oxygen, for example, has the proton number 8. So, oxygen is the 8th element in this periodic table. 1, 2, 3, 4, 5, 6, 7, 8. And this is oxygen. Hydrogen has only one proton in its nucleus. So the proton number is 1. So hydrogen is the first element in the periodic table. And you'll find hydrogen over here. So arrangement and where they are found depends on their proton number. If you have the proton number 26, you will be the 26th element in the periodic table. But why is the periodic table such an odd shape? It has 2 elements in the first row or period, 8th in the second and third, 18 in the fourth and 32 in the sixth. The 6th row is so long that elements 58 to 71 are normally taken out of it so that the table fits conveniently onto a sheet of paper. And you will notice that the periodic table has a slightly odd shape. It sort of goes the first row with just 2 elements, as we said. Rows 2 and 3 have got 8 elements, and then 4, 5, 6, 7, the elements start to increase from 16 to 32 and then higher. Why is the table so designed? Understanding the periodic table helps us to understand why elements behave as they do. Now, the reason that the table has got this odd shaped design is because it's not just telling us about the 100 or so elements we have in the table, but it's telling us key information about these elements. Things like their chemical properties, physical properties, where we should find them, how many valence electrons they have. All this information can be gathered from the periodic table. We'll see how in just a moment. Arrangement of elements in the periodic table. Systematic arrangement of the elements in the ascending order of their proton numbers enables us A. to study the chemical properties and physical properties of the elements and compounds systematically. B. Predict the characteristics of an element and its compounds based on its position in the periodic table. So the 2 key things that we can get from the periodic table is that we can study the properties of elements and we can predict properties of elements based on their position in the periodic table. Historical development of the periodic table. Antoine Lavoisier. Contributions. Classified elements into 4 groups based on their chemical properties. Example, group 1 elements were oxygen, nitrogen, hydrogen, heat and light. Group 4 elements were metal oxides. J.W. Dobryna, the triad law, divided the elements into groups of 3 elements with similar chemical properties. Example of the groups: lithium, sodium and potassium, chlorine, bromine and iodine. John Newlands, the octave law, arranged the elements according to